Hi, questions in topology. In this textbook, problem 17 in chapter 3, let X be a locally compact Hausdorff space, which is not compact. Form a new space by adding one extra point, usually denoted by infinity, to X, and taking the open sets of this new space to be those of X, together with sets of the form X minus K union the infinity, where K is a compact subset of X. Check the axioms for a topology and show that this new space is a compact Hausdorff space, which contains X as a dense subset. The new space is called the one-point compactification of X. Solution: let X infinity denote X union the point infinity. The empty is open in the space X, so the empty is open in X infinity. We also see that X union the point infinity is open in X infinity. Consider this union. Then every K mu is closed. This says X minus K mu is open in X. We have this identity. If K is empty, this union is equal to X union the point infinity, which is open in X infinity. If K is not empty, then K is compact. We see this identity. We see that K minus G is compact in X. Therefore, this union is open in X infinity. Consider this intersection. Then Ki is closed in X. This says X minus Ki is open in X for any I. We see this identity. We see that G0 is open in X infinity. And we have this identity. Note that a finite union of compact subsets of the space X is compact. So K0 given by this union is compact. So this intersection is open in X infinity. So this intersection is open in X infinity. We thus conclude X infinity is a topological space. For two different points, x1, x2. x1 and x2 can be surrounded by two disjoint open sets. For every point x in the space X, the point X has a compact neighborhood K with an open neighborhood Q contained in K. Then we get an open subset of the space X infinity. And the point infinity is in this open set. The point X is in the open set Q. And those two open sets are disjoint. We thus conclude the space X infinity is Hausdorff. let G lambda be an open cover of X infinity. Then G lambda can be expressed by those two forms. At least one member of this open cover contains the point infinity. Write this member G0 given by this form. Then we get an open cover, this one, of K0. Then we get a finite subcover. Then we get a finite subcover for the space X infinity. We thus conclude the space X infinity is compact. We see that every neighborhood of the point infinity contains at least one point of X. This implies the point infinity is a limit point of X. We thus conclude that space X is dense in the space X infinity. Thanks for watching. Bye.